You may be wondering why do we need to talk about addresses of things in memory? Why we have to discuss all of these little pieces of syntax, such as this asterisk that I'm using here and those square brackets. And the reason is that in object-oriented programming, pretty much most of the principles in object-oriented programming are actually end up being the facilities that manage computer memory. And when we talk about dynamic polymorphism, or when we talk about inheritance of classes, when we talk about pretty much like other facilities, for instance, interfaces in Java, virtual functions in C++, and other aspects which essentially high-level abstract concepts, it's interesting that all of this can be visualized in computer memory. But if I started to show you that visualization without explaining to you what a pointer is, which is a variable that stores an address in memory, that would be a very difficult proposition. So I prefer that we learn that you can have variables that contain addresses of objects in memory. And I don't think it's very difficult. I'm trying to run these demonstrations for you so you can visualize what's going on, right? Listen, if you have a sequence of characters such as hello, and you know that it's a sequence of characters stored someplace in computer memory, I don't think it's very difficult to figure out that the first character has an address and the second character has an address. And what if I wanted to store the address of that character? Well, here you have it. I can have a pointer. Um, so uh, the notation that I've used, say, if I wanted to display the second character, I can say that the offsets, if I have already the address of the first character, right? So the offset of the first character is 0, the offset of the second character is 1, then 2, 3, 4, 5, and so forth, right? If I had a longer string, I could essentially create a ruler like that. So if I said display character at this address plus offset 1, then sure enough it should display, right? If I build this again, it should display, it should be able to display character E, because now I'm talking, essentially what I'm doing is that this expression greeting 1, what it does, it is essentially is asking the compiler to go at this offset, which is the greeting, right? So this statement here basically takes me here and takes me to this location, right? And then it says, then count 0, 1, and at this 0, 1 location, basically extract this character out of memory and pass the copy of it to cout, and so cout has a chance to send it to character output device and eventually display it so that we can see it on the screen, right? So if I specify index 1 or offset 1 with the square bracket notation, if I build this and if I run this, you see that now it displays character E. So this square bracket notation, is useful when you have sequences of elements such as string of characters. It's a sequence of characters, and therefore it's convenient to use the square bracket notation to refer to individual characters if I wanted to refer to the individual characters in this program. But if at the same time, if I wanted to say, let me just turn the page and for a second forget about this text and try something different. I could try, let me just get rid of this, right, and try something new. I say if I have an integer named integer a equals 1, okay, and integer b equals 2, like this, and then integer c equals a plus b. Okay, so I have code like this. Perhaps I can copy it and paste it right here so I don't have to jump between different places. Just paste it right in like this. Okay, good enough. And so once again, I will do the little drawing of my memory. Okay, and so this time what I have is, I'm assuming these are all local variables A, B, C. Now remember, I discourage you from using single character variable names because they're very difficult to maintain and understand. But in this demonstration, it's appropriate because they have no meaning other than numbers stored someplace in memory, right? So it's likely that character A is allocated maybe right here in memory. Character B is allocated somewhere here. Character C, I'm sorry, integers, right? We use integer number in memory, right? So we store 1 in A, and we initialize rather B with 2. And what happens is that when this program executes, these values are extracted. A plus operation is performed, so plus results in some kind of temporary value. Of course, it's an integer number 3, and it's used to initialize variable C with the value 3, which is 1 plus 2, right? So this is 1 plus 2. Temporary value is computed, and it's stored in this variable 3. Now, what if I wanted to do something like this? Instead of doing arithmetic addition, right? Instead of doing this arithmetic addition, what if I wanted to have something that instead would be able to exchange these two numbers, right? What if I wanted to make 1 look like 2 and make 2 look like 1, this variable b? What if I wanted to swap the values? Well, perhaps I begin to think about what the possibilities are. First, I could assign A equals B. So let's just go back to the original values and actually, let's go back to the original values right here. A is 1, B is 2. And I would like to swap these two values in memory. So first I could say A equals B. So this way I'm taking 2 and assigning it to this location. So I would have, so 1 is gone, right? And instead I have 2. So I actually lost the value of A. So therefore, before I do that, I need to be able to preserve the value of A because I'm losing it if I'm assigning B to A, right? So maybe I can use C as a temporary variable and say C should remember the value of A. So this way, right, I'm preserving the value of 1 temporarily. I use this as a temporary variable, variable C, and now I can safely assign B to A, right? And then, of course, B, for me to exchange those values, I need to assign this temporary value to B. And therefore, to be able to swap values, I need, my observation is that number one, I need temporary value. Otherwise, I cannot just use variable assignments. I have to preserve the first value. And number two, Number two, I can use assignment, which is this, the equal sign, does the assignment, essentially transfers value from one memory location to another memory location, like this in this last statement. Okay, this sounds fine. We can even experiment with this. But remember we discussed functions last week? And so my question is, what if I wanted to build a function, say void function? Void means doesn't return anything back. A void function named swap, okay? And this swap would take the integer value, I'll call it left, and integer value right? Two integer numbers. And this function is supposed to do my exchange, right? So we can say integer temporary value equals left. Say I preserve, we can say left is preserved. Since it's preserved, we can safely assign left equals right, left equals right. Okay, and then we can say that finally, since we preserve the value of left, then we can say right equals left, and mission accomplished, right? So these two, I'm sorry, temp, right? Temp. Right equals temp, and this mission is accomplished because what we do, basically, if you look at this quick drawing of it, that would be something like this, right? So we have three variables. We have variable, first of all, let's talk about this function in general. Let's actually, first of all, I have an extra brace over there, but let me copy and paste this so we can have it in view. Somewhere here, and we paste it in. So this is our function, like this, and of course what I'm missing is this closing brace right here, right? We need to have a closing brace, and we have this temp right, and we have left. Somewhere we have these three locations, and what happens that when we do our assignments, first we say left goes to temp, then we say left equals right, left equals right, we do an assignment like that, and eventually we do temp equals right. So eventually we do something like that. So we transfer these values, and the end result of it is that the values are swapped. And so we're trying to call our function a swap function. We manipulate those assignments.